Okay, so today what we're going to do is talk about creating a LAMP stack with Docker. We already did this previously using Alpine, and we're going to talk about some of the pros and cons and getting started with Docker, as well as just an introduction to what Docker is and how it sort of basically operates. So this is the slide that we previously introduced Docker and Podman and what containers are. Essentially, using the images from the Docker website, you can see that Docker essentially containerizes or sets apps in their own ecosystem or their own environment, runtime environment. And it does it using its own sort of daemon or service that runs on top of the host operating system. Whereas if we were running virtual machines, every virtual machine has an entire guest operating system of overhead to run multiple applications. Now, if we're just doing a basic test bed, the virtual machine may or may not be the way to go. But what the advantage with Docker is it's very scalable. And, if you run past a few containers or whatever, it's very easy to leverage what you've done from one container to another container, as well as the host operating system's kernel itself. So it allows Docker to be a little bit more scalable and also very fast and very easy to set up. So let's talk a little bit about that. So what I'm going to do now is I'm going to go over to this file manager. Now what this is here is we're connected to an SMB share, which is not where we're going to run the environment, but it sort of shows you sort of the layout that we're going to be looking at. So in this SMB share, we go up one, there's this Docker LAMP, Docker LAMP. Remember, LAMP stands for Linux, Apache, MySQL, PHP. In here, we have this Docker Compose YAML file or YML file. So let's open that with text editor. So we can sort of see what this Docker Compose YAML file looks like. Docker Compose is an easy way to set multiple containers within a single file. So what it does is you essentially claim a single version on the file. Once you have that version, then you'll have your services set up over here. Each file, or each, I should say, container gets a name. So you can name this like MySQL contained, web server contained. Maybe I'm just going to call this web server just for simplicity's sake. We have phpmyadmin, just like we added in the Alpine tutorial. So essentially what we're going to do is set up the exact same configuration, but all of this is scripted. All of this is within the same file. Now, when running Docker Compose, I think this X is a typo. I'm going to save this. When running Docker Compose, you need to make sure that Docker is installed. So let's exit out of this. We'll go over to Docker. So this is an overview of Docker. You can see again, it has container and then it manages images. Containers leverage images, and we can talk a little bit about that and how that works in just a moment. But essentially, once you have an image, it gets downloaded. If you wanted to create multiple containers leveraging the same image, you can. So that's where Docker sort of really consolidates space and sort of decreases sort of workload overhead, which virtual machines can't do because they run whole individual operating systems by themselves. Then it can also manage the network, it can also manage data volumes. All of this can be set up in the services themselves. If you need to learn a little bit more about installing Docker, you can also just go to the Docker docs and we can just type in installing Docker. So get Docker, install Docker, and then Docker can be run on Mac OS, Windows, or Linux. With Mac OS or Windows, the approach is more dedicated for desktop users or developers, people who need to set up an environment quickly. So it oftentimes includes Docker Compose out of the box. For setting up with Docker Linux, you need to install Docker Compose separately if you want to use Compose, because Docker can create containers in multiple ways. And we'll talk about that in just a moment. But if we're using Docker Compose, so we have this set up, what we're going to do is we're going to follow this. We are going to also create a Dockerfile. So what we want to do is in our Docker server, or the server that's running Docker, again, this can be your desktop PC as well, but we're going to set up this kind of subsystem. So we're going to have one folder, which could be Docker lamp, which is what we have here, this folder over here. We're going to set up this lamp contained. This is going to be the folder which we then access for the build. Inside the build, we're going to have a Dockerfile. Dockerfile looks like pick a default program. This does this. We'll talk a little bit more about what Dockerfile, but essentially it gives us the ability to do a few more tasks which we can't just handle directly by running the Docker Compose. And if you have this sort of build call here, then you need to have the Dockerfile, and it will look for that build inside this lamp contained folder. So we'll talk about that in just a minute. But what we're going to do is we're going to set up 3 directories. So let's do that now. Let me SSH into the server. Okay. So we have a couple of folders here. We're going to make a new directory. We're going to go into that directory. And now we're going to make another directory. This is exactly the same as what we have here, this lamp contained. So we're going to go lamp contained. Then we're going to go inside lamp contained, so cd lamp contained. We're going to make another directory called data. Okay, so essentially at this point we have the same kind of directory stack that we just did, or already had previously set. Now what we're going to do is we're going to create this Docker Compose YAML file. So I'm just going to highlight the whole thing. Press Control-C. Inside here, I'm going to use nano, which is my command line text editor of choice. We're going to type Docker Compose .yml. Okay, so we're going to essentially create this file. Then we do Control-Shift-B. Now, the thing to be careful about inside these YAML files is making sure that the spacing is all homogeneous. What I mean by that is all the indentations. I had run into this problem when I was first trying to create this image, or this runtime, was the spacing got away from me by accident. And if the spacing isn't 100% homogeneous, for example, if you start with a spacing of, say, 2 spaces, then the next tab in, or the next space in, for whatever subset of that in YAML, needs to be 2 spaces. These hyphens here, or these lines, are just 1 space in, and then 1 space for the rest of the command. And you need to be very strict about that, because otherwise YAML won't really understand exactly what you're doing. Version 3 tells you what version of Docker Compose you want to use. I think version 3 is still sort of the default standard right at the moment, although I'm sure there's newer versions available as well. But version 3 works quite well for this particular setup. What we're doing is we're taking an image, a Docker image, which is called MySQL 5.7. We're setting a password for it. So this is the root password for this MySQL container. Again, we're just calling it MySQL pwd. We're also telling it what ports it should run on. So we're setting it saying the host port, this 3306, this would be the host port, needs to route to the Docker port of 3306. So we're just mapping that exact port number. On the web server, we're doing a similar thing, but we're actually building it. And by building it, it allows us to slide load additional variables via the dockerfile that we just showed. And I'll talk a bit more about that in just a sec. We're assigning a volume for this web server. So we're saying, okay, the default data, or where you're going to look for the data for your var www.html. And again, this var www.html in Debian and in Ubuntu is where Apache gets the web directories. So if we have something like home.html, it'll look inside var www.html for this home.html, which would be the homepage for, say, like a website or something. We're setting the ports here. So you're setting up the ports file, and again, we're mapping the host port of port 80 to this port 80. We're linking the system to this MySQL contain. So we're linking the two services together. So this MySQL contain service that we called forward up here is getting linked to web server. So web server knows that it needs to rely on MySQL. It depends on, essentially is saying, wait for the MySQL to start up before you start up. So that way we make sure that the database is already available before we start the web server and log in. With phpmyadmin, again, we request this image, phpmyadmin. This is a Docker image call. It essentially goes to Docker Hub, and we can see that over here. In Docker Hub, you can search for things like phpmyadmin, and you'll get a list of various images that various organizations or parties put out. We're calling in the first one phpmyadmin. Again, this is also where we're getting the MySQL image. So we have MySQL. There's also options for, say, like MariaDB, MySQL Server, something or other. Some of these are by users, some of these are by official organizations. So you can choose which one best suits your needs. What we're going to do is call the MySQL. I did do a little bit of work with the MariaDB one, but unfortunately it wasn't liking working with phpmyadmin, so I'm defaulting back to the MySQL image in this case. So that's why we're calling this MySQL, and then we're specifying the version of 5.7. Then over here, we're just insisting that on the phpmyadmin, letting it know that the phpmyadmin host maps to our database. We're saying that the database root password is the same as what we're setting over there. And then we're saying that the port that phpmyadmin needs to use for connecting to the MySQL contained is this 3306. So that way phpmyadmin knows that it needs to connect over that port. And then for phpmyadmin, we're actually setting a different port so that phpmyadmin is going to run over port 8080 rather than port 80. And we'll show that in just a moment. So we're going to set this up on this remote system. There might be some firewall things that we need to change, but we'll sort of work through that. And now we're going to press Control X, say save changes, yes, okay. That's the Docker Compose. Now we need to go into CD lamp. And I'm sorry, I put that in the wrong container. Let's move Docker Compose YAML. We're going to move it up a directory, so we're going to move it into home. This tilde sign right here is a home / Docker lamp. So we just have data here. So now if we went up one directory, we have the Docker Compose YAML, so that's fine. Now we go back into lamp contained. And again, this is just mapping with the file management that we have. So the compose sits outside of where we then build the environment, which is specified in this lamp contain folder. Now we're going to create a Dockerfile. So again, we just press nano and we just say Dockerfile. It has to be capital D, it has to be this exact thing, and there's no ending or file end to specify. It just has to be a pure Docker file, which essentially is a text document. So we go in here, and again, we're going to take this Docker file. What this does is what we're defining is this Docker file, which comes from the build. So web server build, so we're building a new container, and it's going to look for the build requirements inside this Docker file. And then what we're saying is, you'll notice that the MySQL contained and phpmyadmin, we requested an image. Okay, so we told Docker where to go get this image. We said we need the phpmyadmin/phpmyadmin image, or we said we needed the MySQL version 5.7 image. We did not do that in here because we're saying we're going to build it. And when we build it, we request in the Docker file. So when we request in the Docker file, we say from PHP 7.0 Apache. So this is running an Apache web server with PHP. It's an image which is specified as such. If we looked for it in the Docker Hub, we would also be able to find it. So you have this PHP, and there's many versions of PHP services. So we're just specifying that we want this one, the one with Apache. So we could also look for that here. So you can see there's the Apache Ubuntu or Apache whatever. So we're just specifying which PHP image we're looking for. Going back to the Docker file, we're also telling the Docker file to run this command. So there's this docker php ext install. This is telling Docker to install an additional PHP image or PHP repository. So we need this MySQL I. Again, I think we talked a little bit about this during the Alpine setup, but the MySQL I is essentially a vehicle in which PHP or our website can then connect to the MySQL database. It's where we create queries, and it's where PHP can then connect to the MySQL DB. And we're also going to tell it to expose port 80. This is going to make sure that we have access to the system, access to the web server via port 80. So we're doing these three things in this Docker file. So we're just going to copy that, Control C. Inside here, this is running on our web server. Just do Control Shift V so that we have that. Save, exit. Okay. So we see we have the Docker file, we have data. Let me also just check the read-write permissions on data. That looks fine. So we have this Docker compose here, lamp contained. So now what we're going to do is we're going to, as root user or using sudo, because this is a Ubuntu machine, say sudo docker compose up, and then that's going to run all of our docker compose commands. Enter the password for your root user. Aha. We might have docker compose installed. And again, this is one of the things you just need to make sure that you're running in Linux. So we'll go ahead and install this real quick. And I'll put links to all of this in the notes on the blog. What we're going to do right now is very quickly install Docker Compose to make sure that we can actually run this. And it's pretty quick. And again, for if you're running Mac OS or Windows, I do believe this comes with the Docker install or the default Docker install. Docker also has an install package, I believe it's called Docker Toolkit, which should also include Docker Compose plus the Docker runtimes. So now we can just do Docker Compose help, make sure it's installed. Yes, it is. And then we just scroll up through the commands, so sudo docker compose up. So now it's doing this. Okay, it's not finding the images right now, so it's automatically downloading them. It's downloading the latest images of phpmyadmin and all these other images that we called. So that would include the MySQL. It also includes the web server, which is the PHP 7.0 Apache image. So we're pulling all of this down now. Okay, so the system built, there was an error because the port defined is already being used by another project, so we can check that. With Docker, you can run this command ps. It shows all the running containers, and we do have a container already using this port 80, which is where the problem lies. So what we need to do is we can run the command docker container stop, and we can say this docker lamp web server 1. Control-Shift-C, Control-Shift-V. Okay, stop that. Then controller stop. We got this other one, MySQL contained. And again, these are names of the Docker containers. If we put this full screen, it'd be a little bit easier to see. But when we do the Docker sudo docker ps, which shows running containers, I have this other true command container which is already running. It's also already using the port 8080, which is the reason why the phpmyadmin failed. So you can see this cannot start external connectivity, bind for port 8080 failed, port's already allocated. So what we're going to do is we're going to stop MySQL contained as well. Stopped, and what we're going to do is nano docker compose. I'm going to change this port from 8080 to 8081, so an open port. And we're going to try bringing this up again. Now it should be a lot faster this time because the first time was downloading all the images. So we sped through that in post-production, and we're going to bring this up again. It should be very, very quick because the images are available. If you want to see the images, you can do sudo docker images ls. Image ls. And we can see we have all these different images. Now the nice thing about Docker is that we can have as many containers as we want. If it's a common image that we call, the image doesn't need to be re-downloaded or duplicated in any way. So the image size can be expanded upon or extrapolated to contain all these other images. So for example, like hello world or true command or phpmyadmin or php, whatever, all of these are images which we can then leverage and work with. So what we're going to do is we're going to bring this up again, docker compose up, recreating. Okay, all that looks good. And And again, this particular server, I can show you, I'm also SSH into it over on this terminal as well. We can just check the IP address. And the IP address for it is this 192.168.123.227. Okay. So if we go over there, we actually probably won't see anything. It's forbidding you have access, which is true because we don't have indexing turned on for that default. But what we can do is create a very simple website. cd docker lamp, cd lamp, and data. Now we're going to create index.html, which is going to be HTML, and do a header that says hi there. Okay, we're going to save that. So index.html is the default sort of home page for Apache. So we can refresh. So we get hi there. So that works. The other thing we can do is do a nano php info to make sure PHP is working. And again, we'll just run the straightforward PHP. So we'll run a very easy PHP script to make sure that we're running the correct version of PHP. So we just go over here /phpinfo.php and we get the info. So PHP is running. That's great. So essentially at this point our web server is running. The other thing we can do is check phpmyadmin. So we set it to port 8081. There's phpmyadmin. You have the root. We set the password. And the password as we defined it was should have been MySQL. Oh, sorry. Yep. And now we're in. We can create a database. This is using the root. We can just create a new database. Again, we can do like pizza order or coffee order. Create. We have our database. We can create a table. We can enter SQL commands. We're good to go. That's essentially all we need to do on a Docker stack. So it took a little bit of time just because we had to download all the packages. But very similar to what we did with Alpine. We enabled a LAMP stack, so we have Linux, Apache, MySQL, PHP, all running within Docker. Again, if we want to see what's running, we can just do sudo docker ps. And we can see everything that's running in the Docker containers. You can see 4 separate containers right here. So we have PMA contained. That's the phpmyadmin. We have Docker LAMP web server. We have Docker LAMP MySQL contained. This is essentially the LAMP stack, these 3 containers. I also have this other TrueCommand container. TrueCommand is a management platform from IX Systems to manage multiple FreeNAS and TrueNAS devices. So I have that running as well. And you can see here, all of this is running together. Each one of these is completely independent. And there's other things that we can do from the Docker as well in terms of managing it. So we already showed the Docker image ls. That shows what images we have. again, this is a very useful tool. You can sort of decide for yourself whether or not it fits the bill. I think in our Alpine image, or our Alpine VM, where we created our own dedicated LAMP stack on top of Alpine, we came in at around 1 gigabyte of total size or total used storage space after we install all the packages. I think it was around 900 something. This is actually a little bit larger, just from the images, and doesn't include Docker itself. That being said, if you do need to scale and you do need to have many services or many containers or many test environments, Docker is kind of invaluable for its ability to run firstly on any platform. So you can install it on macOS, Windows, or Linux. If you install it on macOS or Windows, it essentially runs a small Linux virtual machine, which then runs Docker on top of it. If you're running on Linux, the service just runs on top of Linux. And if you want to create like really quick services, or you need to bring something up or bring something down, you can also manually go in and do just sudo docker container stop, and then you can enter the container name. So if we wanted to stop, like say pma contained, we could stop it right now just by doing pma contained. Because we did use Docker Compose, the other thing that we can do is inside this Compose runtime, which is essentially logging what happens in Docker Compose and so on, what we can do is just do Control-C if we want to bring everything down. So doing Control-C does like a graceful shutdown of all the different containers. And then from here, we can also do different things. We can also do Docker contain. There's a whole host of features. Like we can also rename, so we can change the names of containers. For Docker Compose, that wouldn't be useful, but if I say I wanted to rename my true command container, I could name it like tc command. Although I'm not sure if this is going to work for me while it's running. Let's do sudo ps. So you can see the name instantly changed for the true command. So you can set, once you create an image, you can pretty much change it to whatever. The ID is a unique ID which Docker then assigns to it. So Docker essentially plays by the ID, but it knows the names. It knows essentially, from Docker's point of view, would be essentially a nickname. So that's kind of just a quick overview of Docker. Again, the other nice thing that we can look at is I can run a top command. And you'll notice here, we can look at the memory. So we have, this looks like about 257 megabytes used right now by the system. If I was to bring up this LAMP, so we're restarting the 3 containers again, the PMA contained, or the phpmyadmin, the web server with Apache plus PHP, and the MySQL. If we look at top now, we can see we're at 526 megabytes used. So it's a very small amount. You're essentially getting 3 independent systems, self-contained systems. If you were to run this even with Alpine, our Alpine install, we use 512 megabytes of RAM total for the system. And if you were using something like Ubuntu, which is what these stacks are running on right now, or Debian or something, and you wanted to run each of these containers as 3 separate virtual machines, the memory overhead would be much higher. You'd probably be looking at least 2 gigs of memory per system just to be able to run it smoothly in the back end. So that's another huge advantage with Docker. It scales very well. It might not be quite as small as, say, running everything together as services within a single Alpine environment like we did in the previous video, but in terms of scalability, flexibility, manageability, Docker is quite nice. It's also a little bit more straightforward to install, particularly if you're using macOS or Windows. So these are just some of the the quick things that I wanted to show. And again, thank you all very much for your time. Appreciate it.